So my name is Luis Soares. I will be talking about the new features in high availability that help delivering business continuity on your database infrastructure using MySQL. Specifically, I'll be talking about the new Enterprise Edition features that we've developed recently, and I'll talk a little bit also about additional features in the Community Edition as well. So, who am I? I am Luis Soares. I'm born and raised in Portugal. I'm really fond of fault tolerance, high availability, computers in general, and I've been a long time MySQLer for now, 16 years plus going 17, so a long time already doing this. This is the agenda for this session. I'll talk a little bit about some conceptual background, and then I try to split the new features into different categories like observability, manageability, automation, and operability, right? And then we'll conclude this session. So background. It's important to note that there are faults. Faults leads to failures, and then failures can result in errors, and errors can bring down your infrastructure at the end, right? Within this context, there are things that we usually know as recovery time objective, the time it takes to recover after a failure, and recovery point objective, which is the amount of impact of data loss that you can sustain once you deal with a failure. All of these influence things like service level agreements, which is, in a way, a reflection of your RTO and RPO. There are different types of failures. There's normal bugs, there's a server that can go down, there's network that can have hiccups like packet bursts or packet drops. There are more serious failures like a earthquake or a fire, which lead to things like planning for disaster recovery and so on and so forth. And there's even failures that are driven by human mistakes. As a human, we all make mistakes. It happens. It's all about protecting against these, right? So all these things require us to think about how do we make our systems more dependable, how do we make our systems more highly available so that we can sustain this type of failures, so that we can achieve our objectives, time objectives, point objectives, so that we can meet our SLAs at the end of the day. And it's really fun with MySQL because MySQL is a 30 years old technology, right? And from the early days, very early days, it has had MySQL replication in it, right? It has been a framework that has been massively used to build a high availability infrastructure on top of MySQL from a very long time now. Over time, it has evolved throughout many different stages, and there's many phases to MySQL replication in terms of the technology itself. Originally, it was statement-based replication, then it came mixed mode replication, row-based replication. This thing alone fostered not only high availability setups, but also capture data change scenarios and so on and so forth, data integration as well. So the technology itself is pretty proven, pretty battle-tested, and pretty useful. But it's a technology, so on top of this technology, we started developing solutions, right? MySQL InnoDB replica set, where you have a very nice package that delivers to you as a user all the automation, all the ease of use, all the infrastructure to quickly set up an asynchronous replication using MySQL servers, right? We delivered as well MySQL InnoDB cluster, where you can easily, again, a package that can easily give you a way to set up a cluster very quickly to deal with the type of failures that we were talking about earlier on in a more HA type of scenario, right? And there's also MySQL InnoDB cluster set, which gives you a way, again, a package for you to deploy a disaster recovery type of type of architecture where you can connect clusters that automatically manage themselves and automatically reconnect from one cluster to the other in case the endpoints go down and so on and so forth. So this is pretty neat and pretty interesting things built on top of a proven technology. And I couldn't stop talking about solutions when we have the MySQL or the HeatWave MySQL service as well, which is a managed service where a lot of this automation lives and breathes as well. So a lot of this, let's say, operational overhead, or a lot of this manageability, a lot of this automation is implemented by the service for your own benefit as a customer, right? Where you can just go in and launch a DB system in HeatWave, and you get all these things behind the scene for free. Specifically about HA, for instance, right? So one thing that is common across all these different solutions is there are some needs that are shared across all of them. The need to observe, the need to manage, the need to automate, the need to operate, right? Whether it's you that have the need to manage, observe, deploy, operate, automate, because you're running something that is self-hosted on-premise like MySQL InnoDB cluster, or whether it's the service that needs to run HA for you and so on and so forth, there's always the need to make sure that we are able to understand how the system is living and breathing, how to understand what we should do in case there's some corrective action that needs to take place, right? So when we talk about observability, usually we talk about, okay, what metrics do we need? We need alarms, what type of signals do we need the system to send so that we know how to react, so that we know how to build automation to react on top of those signals and so on and so forth. Sometimes we don't have yet the automation, or the automation is not quite there yet, and then there are runbooks that have to be written so that operators go in and fill in the gap, right? Sometimes when we talk about manageability, we're talking about, okay, now I need something here to enable, disable this part, I need to track this behavior here, and so on and so forth. I need to take action if I need to morph the system into something else. And automation is crucial, right? It's okay to, every now and then operate or do this and that tweak, but automation should be king in this scenario, right? Automation should drive the system. And that's what we've been trying to, over the years, to build more and more automation into the HA infrastructure of MySQL, remove some of the burden from the user, and deliver a much better user experience to the end user. So with that in mind, I'll talk about a few of the features that we've done over the past 12 months or so that allow us to continue down this path, right? So observe. When we talk about observability, in particular in replication, we're talking about trying to understand, trying to see how things go, throughout the replication topology. We cannot think about a single instance. We need to think about instance A, instance B, instance C. They are all interconnected. End-to-end observability, which then translates into, when I think about latency of a data change in my cluster, in my topology, I need to think about how much time does it take for this change to go from whatever it started, whatever it was initiated, let's say a primary or a source in replication language, to a replica, a leaf replica in my topology, right? We also have to think about throughput, because throughput should be balanced across the replication topology. If I'm just hammering my primary with a lot of workload and it's going full speed ahead, but it's creating a backlog of data on the replicas or secondaries or whatever downstream, it's likely going to cause problems later on, right? So we need to think how to observe this, how to balance this. First of all, how to observe this, and then think about how to balance, how to react to these data points, right? So there's a drawing here that says, okay, there's a timeline, and then there's some execution on the source or primary, and then these changes are propagated to the secondary or the replicant, and they are applied. And then if you know group replication, you know, for instance, that if this is a primary and then the other one is a secondary, group replication itself has some ways to tweak when should the application get an acknowledged back that the transaction was committed. Is it immediately when it was acknowledged by the secondary, or is it after the secondary has applied it, and so on and so forth. So all these things have to be considered into your observability. So network connectivity and communication protocols observability is an important thing, and they should both be observed thoroughly. So this is not new. This is actually something we implemented some time ago, but I think it's a good leeway into the rest, right? So we built a lot of observability, new metrics into the replication protocols of group applications so that we could measure things like network latency, round-trip communication latency, consensus duration, and so on and so forth. Why is this important? I'm not going to explain everything on this slide. The two things that are really important are there is a replication protocol at play here, and there are certain optimizations that can be enabled during runtime. These optimizations can be skipped if there are certain conditions in the environment, like higher network connectivity latency, or packet drops and so on, that will make the protocol adjust and therefore not enforce the optimization. So if we think that, oh, my cluster at some point was committing transactions at 10 milliseconds per second, all of a sudden is now committing transactions at 20 milliseconds per second, why is this happening? And one way to do that, one way to figure it out is to go and look at these stats and figure out that, okay, seems that the latency, network latency-wise, something happened. And therefore, this rippled into the communication protocols of group replication, and then we're seeing some additional latency. So we can, at that point, looking at the metrics, realize that the underlying infrastructure is actually the root cause of the problem. So anyway, there's some interesting blog posts about, very deep Paxos and GR implementation of these replication protocols. They're just here for reference, but I'll skip that. So this is just a summary of the metrics that we exposed earlier on. I'm not going to go into the details here, but they exist. This is an example of the metrics that I was talking about earlier. So yeah, that already existed. So in the same trend, we now want to, okay, we already can measure the network connectivity, the interconnects and whatnot. We want to also have extended metrics about after I deliver a transaction to a replica, how much time it takes for this replica to, receive it, apply it, and so on and so forth. We already, in MySQL, up to these latest versions, we already have some performance schemas tables that show us some of those metrics, but now we went a step further. It's important to see, okay, it's interesting how much time, how much relay log this space is used. That's already there. But it's interesting to understand how much time it takes for a change to go through this relay log itself. And it's also interesting to see what are the applier threads that receive the changes from the relay log and apply them to the database. What are they doing at any given point in time? Why are they stuck? If they're stuck, what are they actually stuck on? And so on and so forth. So what we try to do is to instrument more of the applier and extract things like, okay, we know that we have a multi-threaded replication applier, and we know that it can sometimes wait for certain things to happen. Maybe there are transactions that are conflicting or dependent. Maybe there are not enough applier threads. They're all, completely used at any given point in time. So we can go into these new performance schema tables and extract these metrics. In this case, we see that there were 70 waits due to the fact that there were not enough applier threads available to process the replication log, right? There are some additional waits, like there are dependent transactions that I need to wait for to commit before I schedule the next one, and so on and so forth. So this gives you hints like, okay, now I know that I can increase the number of applier threads because there's room for me to utilize more threads to apply replication content, right? This is one of those cases. In this other case, we can look at and see, okay, there's one applier thread that is actually stuck. I don't know exactly what it's doing. Let's go and have a look, right? We have this new performance schema table that will tell us, okay, this transaction, this worker thread here is actually applying a DDL, possibly a long-running DDL, like an altered table at index or something. This is why it seems like it is stuck. So it is not, right? It's applying the DDL. I can go and look elsewhere in performance schema exactly what it is doing, what type of DDL, and so on and so forth. We've also added more instrumentation for flow control. So flow control is pretty interesting because in GR, it's the mechanism that even if you're just running massive workload through the primary, the system will adjust itself so that there's little lag on the secondaries. Why is this important? Because if the primary goes down and you switch over to one of the secondaries, if it is lagging and it has a backlog, one will probably have to wait for the backlog to be applied, and only then it becomes available as a new primary. So the failover latency in that case would increase. So flow control takes care of not letting the cluster run imbalanced, right, in terms of where the different instances are in time with respect to the replication load. So in this case, we can see that, okay, flow control was activated. It throttled twice. The last time it throttled, it was at this point in time, and this was, more or less the amount of time that it throttled the system. This is important because flow control is not a simple thing to adjust. You might, depending on the workload, you might have to adjust back and forth. And this gives you an idea of, okay, I'm actually running fine with no lag on the secondaries. Should I relax flow control and see if it continues to do so, and so on and so forth. So if you do that and you try to tweak it, you can go here and see, okay, flow control is, I relax flow control, it's still not kicking in, we're good to go with the current workload, right? So, observability. Observability is good. We have more metrics. More metrics means that we can understand better how the system is reacting, evolving over time, so that can be used to drive automation, right? We have done some recent automation extensions prior to 12 months ago, so they're still recent, but we have more things within the last 12 months. But I would like to call out these ones here, which are really interesting. So things like the server automatically recovering relay logs when when the server crashes or storage is just corrupted and the server restarts, it is able to go in, fix the relay logs, and resume replication from what it was, which is pretty good because it doesn't need a human to go in and fix it altogether or just remove the relay logs, right? Also, automatic primary keys is a feature that was introduced some time ago, but it's really interesting because the server will take care of those cases where people don't actually have primary keys to tables, which is a relevant thing when we talk about replication and so on. And one of the things we did in A3 as well was the system, so GR, Group Replication, the cluster, the cluster itself has this service which is the membership service, and this membership service keeps track of which instances are in and out of the cluster at any given point in time. The fact is that every time that there was a membership change, a new transaction, a new system transaction would be automatically generated and the new GTID would come up. So we removed all of that in 8.3, and now the system is able to reconfigure itself, change the membership, without having to introduce new system-generated transactions. This is important because if you're doing things like DR and you have two clusters and all of a sudden the cluster that was a standby shows up with new transactions, you start wondering, what's going on? Did I mistakenly write to this standby cluster? But in fact, it was not. It was this system-generated transaction. So it eliminates all these corner cases, and therefore automation can breezily go breezily go in and do the switch over between clusters and so on and so forth in a DR scenario, right? So what we've also done recently is we have this thing. Yes, we have flow control, but sometimes instances can go into a very unhealthy state where they misbehave and they start swapping aggressively, they get really slow, and then they slow down the entire cluster as well. So with this extension in 9.2, we added the ability to realize that one of the instances within the cluster is actually going unhealthy, extremely unhealthy, and that it could potentially be a harmful thing for the rest of the cluster, so we automatically evict it from the cluster. So this means that it's for all practical purposes and intents, the instance is actually down, right? It's just that it's very unresponsive, but we don't want, so it's very unresponsive, but still communicating with the other two, right? Somehow. So, but we don't want is that this extremely unresponsive instance to the end user being still communicating with the other two instances saying, I'm alive, I'm here, I'm okay. We don't want this to happen, so we, with this extension, it will, the resource manager in a way, will realize that this instance is unhealthy and remove it from the group proactively without having, to go in a human and say, okay, this looks really weird, so let's just remove it from the picture, do some forensics, and so on and so forth. We've also added this feature to, on failovers, choose the most up-to-date primary. Yes, there's flow control. Sometimes there's some imbalances that can happen. Maybe you just added the instance back to the group. It has recovered, but it has a little bit more of backlog than the other instance in the group. So if there's a failover at that point in time, you want to pick the secondary that was closer to the primary that failed at that point in time. So this feature or this extension here adds these policies to the group replication promotion mechanism to say, okay, I gathered all the lag of the different instances in the system, and I know which one has less lag, which one is most up to date. So I'm going to pick that one as the next primary. Again, this is important because it reduces the failover time. Because if you fail over to the secondary and it still has backlog to apply, you have to wait until the backlog is applied before you enable the primary to the application. So manage, there is some new feature in MySQL, which is an option tracker. And this option tracker collects some stats about, okay, what features have been used more recently, right? More recently, right? And we added, so we also added replication features to this option tracker mechanism. Yes, there's already some additional things like system variables, status variables, and performance and information and C schemas to understand what is used here and there. But we also have this new option tracker. Details are on this URL here in the slide. But what I'm actually referring to here is we within this option tracker, we registered some replication features within it. So you can go in and see, okay, if I consult my entire fleet of MySQL servers, I can see more or less who's using what, with how much frequency, and so on and so forth. So it can help potentially drive operational decisions. Should I, I need to do some things that will impact the bin log or replication in that area of my fleet. Let's do it when we have a less usage of this feature, and so on and so forth, so that the impact is not as big. So operate, we talked about observing, we talked about automation, we talked about management and creating plans based on the type of usage of our clusters. And now the last part is, okay, but if I do have to do, to go hands-on and actually do things into the system, is there anything more interesting and recently that can help me? There are certain things that, there are many things in MySQL that help you operate. That's why MySQL is so popular. But that's part of the reason why MySQL is so popular. But in addition, there are these new features as well. Like you can, okay, I need to do some admin command on my, or some operational command in my server. Let's tag this special transaction with a special tag. So you have the GTID and you have a tag describing what this transaction actually did. Like this is an admin transaction, so it flows with the replication topology as well. So you know and you can track what that operation was across your topology. So I'm referring to global transaction ID tag. So with this feature, recent feature, you can actually tag transactions that are related to operational jobs that you do on your data to understand, what was done when and where and where is this operation going, and so on and so forth. One of these things could be, just granting a privilege to a user, for instance. And of course, when you talk about operations, I couldn't leave out the MySQL Enterprise Backup, because it's a very useful tool to take backups, restore, seed new instances in a replication topology, and it comes with a lot of features on its own. But one interesting thing that has happened and might facilitate operations is starting on 8.4.3, I think, as it is stated in the slide. Starting on 8.4.3, we can actually use MySQL Enterprise Backup across different versions. So, meaning a more recent MySQL Enterprise Backup can actually restore an older version, and the opposite, I think, is also true. But it has to be an MEB version that is more recent than 8.4.3. And by the way, in MySQL Enterprise Backup recently, we also upgraded the LZMA library. So it's, compressed backups take less storage, so it's more efficient now, and some additional bug fixes. So some considerations. The road doesn't end here. It's a continuous thing. It's a journey, right? We want to make HA better. We want to make HA easier to use. We want HA to be more automatic, right? So this is what we've been doing over the years. It didn't start like 12 months ago or 24 months ago. It didn't start 10 years ago. It started before that, right? So it's continuously over the years we're trying to make MySQL easier to use. And a lot of these new things as well come from the fact that we actually need to come from learnings that we have done because of the fact that we actually need to operate, maintain, run it within our service as well. So some of those metrics that I explained earlier on, for instance, are things that we saw, okay, the need for in our service. Some of the automation plugins is also something that we thought, okay, in these cases, it would be nice that servers just remove themselves from the equation. I was going to talk something about the MySQL HeatWave service, but I'm running out of time. I think at this point everybody knows more or less what the HeatWave MySQL service is. So just to conclude, observe, manage, and then automate, automate, automate. I don't want to do things myself. If I have to, I will, but then I need the tools, and MySQL gives me the tools and the primitives for me to operate. A lot of the things that I talked about come with MySQL 8.4 and MySQL 9, so I strongly suggest that you go, test it out. Some of these things are Enterprise Edition features, so as you can see, there's added value there as well. So that concludes my session. Thank you very much.